Alright, we're going to go into Scatterplots, which I think is pretty easy for you guys. It's mainly just knowing how to read the data. Okay, with Scatterplots, our vocabulary, you have bivariate data. When you use two variables to measure a person, place, or thing. Okay, and then you have your scatterplot is a mathematical representation that plots pairs of data on an XY graph in order to reveal the relationships between the sets if one exists. Okay, you have your different types of association. This kind of works with the slope that we went over. So our first one we have is a positive association. If you notice, it's going up. If we did before, if we drew our little man's going up the mountain. That is when your X increases and your Y increases. So they both get bigger, so you have a positive association. The next one is your negative association. This one, if you notice, it's just like if you put your man at the top of that mountain, he's going down. So you have your negative slope. Here is when your X increases, your Y decreases. And then, of course, our last one is no association, when there's no patterns at all. All right, you have two different types of graphs. Is the linear. Linear is when the data points lie close to a line, so they'll make a straight line. Okay. And then you have the non-linear. If you notice, it has a little curve there at the bottom. So that has the data points lie in the shape of a curve. So linear versus your non-linear. And then you have your outlier. So outlier is, think of the outside. It's out from everything else. And then when you have a lot of data points together, that one is called a cluster. And here we have the vocabulary where a cluster is a collection of points that are close together. So for our first example, okay, we're going to construct a scatter plot of the weight of an alligator at various times after hatching. So go ahead, plot your points. Make sure you label your axis. So here we have to determine which is my X and which is my Y. Okay, so we know our X is my weeks. Okay, so it depends on how many weeks it is for the weight of our alligator hatching. Okay, so here we go. So here's how the graph would look like. If you notice, it is linear. Example 2. So here we're just going to describe the association, if any, among the observed data. So if you notice, as our X values get bigger, our Y values also get bigger. So we have a variable association. If here it says as the amount of money increases, okay, the cost increases, therefore the scatter plot shows a positive association. So as your X get bigger, your Y's get bigger. Okay, we have a linear association. We don't have any clusters that curve, so the line, the data on the line lies close to the line. And then our other patterns, there are clusters, it looks like around 1 and 2 gigabytes of memory. That costs between $30 to $75, and it does not look like there's any outliers. So all we're really doing with scatter plots is just trying to read the data, okay, and knowing the different types of data that it will show. All right, so now you try. So here I want you to do is to describe this association, just like what we did on example 2. Determine if it's positive, negative, or no association at all. If it's linear, non-linear, if you have clusters or outliers. I just want you to write all those down. I will check that in class tomorrow while y'all are watching the movie. Pause if you need to anytime during the video. Okay, this is your second you try. I want you to do the same thing here. Go ahead and describe the association or everything that you see on this scatter plot. Okay, our example 3, now we have a table. So this table shows the public school environment from 1999 to 2010. Okay, here's the graph once everything is graphed. If you notice here, we have a positive association as our x values get bigger. So as the years go higher, the number of students also increases. So we have a positive association. It's also linear. We don't have any curves in there for a nonlinear association. And there's no clusters or outliers here. Alright, here's your you try. So here we have described the association. If any of the observed data, if an association exists, make a conjecture, so make a statement about the winning time in the 2020 Olympics. So here you're going to have to predict because it stops around 2016. Oops. All right.